What's up, people? Thanks so much for that awesome intro, Cora. Yeah, I got a new track for y'all today. I got the screen share up, and you might see it or you might not. I don't know. That's up to the show producers. But if you don't know me, I come from the Flux project. I come from Kubernetes, developing on a lot of the cluster lifecycle parts. And so when I think about platforms and when I think about building up the stack, not just what database you're using, not what bundler you're trying to put all of your JavaScript and images into to optimize them for the browser, but really the stack underneath, the fiber in the ground, the electricity that's running through our stacks of computers that we got lined up in our co-location, our crazy AWS bill that we got going on, the full stack, right? When we deal with infrastructure, these really heavy pieces of machinery, whether it's a load balancer, whether it's servers or network attached storage or some kind of direct access storage that you got set up, that this stuff has gravity, right? And when we are trying to compute across the infrastructure as a service stack, whether it's compute, networking, or storage, we find ourselves as practitioners, I think, doing a lot of glue work. And my history that led me to Kubernetes and to GitOps with Flux came really from the day-to-day pain of gluing things together. And this might be resonating with some of you. I wish I could see your faces. I wish I could be with all of you right now. But I hope that talking about this pain is helping you kind of feel a little bit of my story. And so I grew up in LA. I'm a Filipino American person, right? Filipino people love karaoke. I grew up dancing. Filipino people love to dance. And LA, Glendale, California is a very diverse place. Everyone from Armenian to Asian people, Mexican people getting all together. And I joined this dance team and I learned about hip hop. And the funny thing about hip hop is that it's a way to communicate pain. All good hip hop comes from pain. So I'm gonna start playing a little track for you. I got in the background because I got a story to tell about a time when I was opening up my laptop trying to do something cool. Yeah, because I'm working command line. My app is so clean. New stacks, my code slaps, libraries are pristine, keeping it system. Gold routine, setting up a $500,000. It's a new machine. Checking the CI, tests run and fly. Complex regex to get rebase. I am getting my YAML ready. I think it's for Kubernetes. Terraform's the norm. This repo is getting heavy. Yikes. Cause I work 99, 6 days a week, striving for that 5 nines, had me losing sleep. No availability, and my code's pulling on some complexity. Yeah, we doing an induction, put my function in production, munching and lunching, ready to do some number crunching. Ring the platform team, it's about to get worse. Already my third verse, and we're pushing the stage first. 99, 6 days a week, got me driving 5 nines, got me losing sleep. No availability, and my code is this mess of complexity. Yeah, alright, we already lost it. Red lights, wow, haven't shipped, I'm exhausted. Relationships caustic, what's DevOps? This is not it. Shadow IT, communications frosted, who knows what it costed? Spreadsheet, just to cop it. License change, strange, this is someone else's lawsuit. Open tofu, acronyms half true. 2 weeks notice, call me up when we're V2, cause I'm out of here. Yeah, I was working 9 to 9, 6 days a week, striving for that 5 nines, had me losing sleep. No availability, and my code was this mess of complexity. Yeah, the blocks just had the best of me. operators and a CRD. Had the projects free and the cash was deep. Down to the age of 3. Now the box was good and the cash was free. Working online to the age of 3. Yeah, the box was good and the cash was free. I've been working with these blocks since the age of 3. So that's a little bit of the pain, right? And I want to talk a little bit about how we can solve these problems a little bit more cleanly, right? So when we're doing infrastructure work, we glue in all of these pieces together, right? And Cora was alluding in a little bit today. Give me some love in the chat if you're feeling some of this pain. I'm trying to clean it up my track for you guys, and I was, playing with this new backtrack. But when we're feeling pain in our work, it comes, I think, a lot from complexity and from the differences in the tools that we're trying to glue together to build up the stack. I think a lot of people think that Kubernetes is going to come into their environment. They can bring it in, set up the tools, install their cluster. Maybe they're going to know already that they have a second one, but they're like, okay, I'm going to have 2 Kubernetes clusters. And that is going to be the world of my infrastructure as a service problems solved in this project. Kubernetes integrates with all of these wonderful things. I'm going to hook it up to my load balancer. I'm going to hook it up to my storage. I'm going to hook it up to my Git repository. And then you talk to the people who need to actually implement those things. And they're like, man, I don't know about that. We got 500 servers over there that are sort of managed by this old version of Puppet. And then we got the new team over there, and they're playing with a little bit of salt as well. And they're trying to mix those things. Meanwhile, I got 5 dev teams who are trying to support legacy. And then there's those new people over there who are pulling in all of these new tools. I think they want to use ClickHouse. There's like this database I never heard of before. You want me to install this and set it up. And then also we're going to have all of the new stuff deployed into this AKS cluster. Like the picture that you're painting with this fancy distributed computer called Kubernetes, I'm not sure if I see the world so cleanly as you, because I got to glue all of this other stuff together and support what we're already doing, because we have a mission. We're delivering our software to all of the people that it matters to every day. And we got to keep those servers running. We got to keep the load balancers healthy. We got to scale with demand. And so gluing stuff together gets messy. So I want to show you some tools that I think really speak to me. All right, so I'm sharing my screen now. Hopefully my girl April has put it up on the screen for y'all already. This is the Carvel website. If you go to carvel.dev, then this is the Carvel website. So carvel.dev. Carvel says to build on Kubernetes with confidence, right? And I think that this build on Kubernetes is really important because we're not inside the boundary, right? Carvel is about solving cloud native problems, and cloud native problems are going to be coming up from all of these different sources, not even just CNCF projects, but sometimes you're just trying to deal with your Circle CI config. Or maybe you have a Docker Swarm cluster still standing around somewhere. Maybe you're trying to configure Nomad. Maybe you're trying to update your build scanning config in GitHub Actions. Like, there's all of this stuff. And let me tell you, there's a lot of YAML everywhere. So the Carvel toolset is not trying to prescribe you a single workflow. And I think this is really important. It's not a single workflow. It's not do this, do this, do this, use this tool for this. Carvel is a Swiss Army knife of tools that follow somewhat of the UNIX philosophy. So if you ever use a Linux computer, right, there's cat, which just displays files or puts files into pipes. Then there's this concept of pipes. You can actually take 2 programs that were never designed necessarily to work together, and you can have them pass data through each other with these streams of text. That's how a Unix computer works. So I can cat something, and then I can sed some stuff by using, a couple of regex functions. Then I can maybe do some git operations to change the structure of my file system, and then maybe grep to look for a file that I thought I forgot where it was, right? And so I have all these little problems, and I reach for these single purpose tools to solve my general computing needs. And in the same way, I think we have cloud native problems. And the substrate for cloud native problems is not just raw streams of text, but it's actually YAML. It's a little bit more structured than just random text. So Carvel works like that. We've got these individual tools that all communicate with each other through YAML and can be mixed with other Unixy tools. And so let me just take you through a little bit of a tour of them. Here you see we got 7 different individual tools. 2 of these are controllers, cap controller and secret controller. So those are things that you would install inside of a Kubernetes cluster to glue some other stuff around. But the 5 CLI tools I really want to spend time on talking through. We have YTT. YTT is this templating and overlaying tool specifically for solving YAML problems. We also have CAP. CAP is a way for staying organized with resources specifically inside of a Kubernetes cluster, right? So you'll notice the difference actually with YTT and CAP is that CAP is a Kubernetes specific tool, specifically involved with trying to deal with the ordering and grouping together of resources inside of Kubernetes in a way that feels a little bit better for the operator. It's Kubernetes specific. But YTT, this is not a Kubernetes tool. It is only a YAML problem solving Swiss Army knife. Right? So YTT YAML templating tool, we have CAP, which is our app grouping dependency manager thing inside of Kubernetes, just a CLI tool to make your life easier. Basically better kubectl. Kbuild. So Kbuild is not a Kubernetes specific tool necessarily. It is only concerned with helping you solve your tags and digests problem. Image package is a way for storing random bits, whatever you want, whether it's configuration, a container image, program language source code. If you want to store a Linux file system rootfs inside of a container image, inside of a container registry, image package will package up stuff into an image and put it into a registry. Really good for air-gapped environments. Next is our last CLI tool. And this one is probably my favorite. It's the most general of all of the Carvel tools, in my opinion, and it solves a huge pain point. It's called vendor. And vendor is a way for you to write a declarative file that goes and pulls files from other places, whether it's Git, an OCI registry, a Mercurial repository, or maybe just an HTTP resource somewhere on the internet or inside of your intranet, like your private network. And you can get all of those resources, and in one declarative place, you can say, hey, I would like to sync these things into my folder. And that folder could be a Git repository of yours. So it's just a way better system than like trying to rely on Git subtree or Git submodules. It's basically a very lightweight dependency manager. And that you'll see is very complementary with a lot of the other Carvel tools. Cool. So our 5 CLI tools, YTT, I guess I'm missing a meeting now. YTT, CAP, Kbuild, image package, and vendor. 5 independent CLI tools to solve some of the cloud native mess that you might find yourself in day to day as a practitioner building platforms with stuff. But then we also have 2 controllers. First is this secret gen controller. This just solves a very Kubernetes specific problem, which is that people try to split up stuff between namespaces, and they also need a bunch of random bits to bootstrap their applications. You can generate secrets and copy them between namespaces and even at the cluster level using secret gen controller. And then with cap controller, we kind of fuse all of these 5 CLI tools together, and we build a GitOps workflow and a package management workflow that you can hook up to package repositories and consume vendor software, which is also really fun. So, but that's kind of a lay of the tools that are across the Carvel project. We also have some experimental tools as well that you can go and look at. These are kind of the main ones. And if you go to the carvel.dev website, you might find yourself a little bit curious and a little bit empowered to deal with the cloud native mess by using these individual tools to kind of start piecing together a workflow that has less bash scripts, less grep, less sed, less mess, less copying and pasting and repeating yourself. So let's talk a little bit about copying and pasting and repeating yourself and forking and finding yourself in, frankly, the miserable business of managing configuration across all of the YAML problems that you might have. I'm going to talk maybe for 15 minutes about one of my favorite tools in this stack, and it is YTT. Right? So if you go to carvel.dev, you see this YTT. It describes itself as the template and overlay of configuration for YAML structures. It is not producing text documents, and you don't have to count any spaces or anything. There's no manual quoting or kind of type errors that you might run into if you may be using some other tools. And in order for me to fully express why YTT is excellent, I'm going to show you some of the feature set, how it sells itself a little bit. And then I want to show you pain. And I want to show you the pain of other tools. And this is very experiential, right? Remember, I was an infrastructure practitioner before I became a primarily open source developer and then eventually developer advocate in the Kubernetes ecosystem. And so I've used all of these tools for many years, and I've run into a lot of their shortcomings. And I think as infrastructure people and as developers, we all know when we have tools and we need to use that tool, but there's just things that we do not like about them, whether it's like the build system for your programming language or the syntax of a particular language or just some weird quirks about the way that the tool wants you to work that you just don't agree with. And so I want to talk about some of those. So YTT is all of your YAML shaping in one tool. It's structure oriented, it allows you to modularize your config, and it's deterministic. That sounds like two other things that I've used before, right? Let's talk a little bit about Helm. I love Helm. I think that Helm, it was the darling star that our ecosystem needed in order for people to come together and put together all of their configurations into packageable resources that other people could modularize and put their own options on and then deploy to their infrastructure. It's one of the reasons why Kubernetes grew so fast was that original central Helm charts repo. So I'm in here in a beautiful place. This is the Bitnami charts repository on GitHub. And I'm just using the GitHub dev editor here to sift through some of the files. So I've gone to the Bitnami folder here, which has all the charts in it. And then I've gone to the ClickHouse chart. And right now I'm just looking at the values YAML here. And this is the most beautiful and useful part of Helm. I love this part of Helm. The fact that you can, as a chart author, create an abstraction, a place where you can just say, I would like to expose these 14 or these 50 or these 200 options that people can use. They can flip on things, turn things on and off, say, I would like to integrate this add-on with Prometheus. I would like to, in this case, override the image registry I'm using, right? Make sure that I'm asserting that I'm installing this ClickHouse database, for those people that need the database on this particular version of Kubernetes. I want to name it something in particular, set up some labels, turn on diagnostic mode, which is probably some sort of database sensitive setting that has some command line flags, right? And so these are very application or very, kind of software specific pieces in order to optionalize the configuration of something that's very complex, right? Very non-trivial. And so if you go into the templates section, right, there's all of these options I can turn on. The number of replicas, how many instances of the database I need, and I can turn on startup probes and override security policies and whatever this is, right? So this is a ClickHouse configuration that looks to be an XML document. And Helm lets me put all of that into one place as a central abstraction. But then you get to the templating language. And I have to say, this is not my favorite template language in the world, right? So like looking at this config map, it's pretending to be a YAML file, but it's actually a Go template, which is this functional programming language for outputting random blocks of text. And immediately you find yourself in a Go template trying to do functional, pure programming in a hermetic way that's always deterministic. And then you're, 90 columns deep, scrolling over to find that you're including this sort of function thing and then trying to create a dictionary. And then now that you've produced this dictionary, you have to pipe it to a function that is going to give you a new line and then indent whatever you were trying to do in your pure functional programming space. You want to indent that 4 spaces. And this is just really frustrating. Anybody who's ever tried to modify or author a Helm chart knows that trying to please the YAML parser through this functional programming language that's meant to output text, not YAML specifically, is really dangerous. In fact, if I miscounted here, right, or you can see here that this is trying to output a label dictionary, but then here we're also trying to, I even clicked the wrong place. Here, we're also trying to add our own component, ClickHouse label here. And this is supposed to be combined with the labels that are coming from this, and that this 4 spaces here has to match this. And I have to know what this does in order to know that putting this on this line is going to create valid. It's just not fun. Right? But there are some really powerful things happening in this template. There's a conditional here. I don't want to annotate if the values common annotations field is not set in the values file. So there's the power of that values YAML abstraction. So I like some things here, but also I felt so much pain and run into bugs and validation issues from improperly modified Helm charts just throughout my career. And maybe some of you can relate with that, right? Also, Helm is not a simple tool. It's very monolithic. And it's also got a very imperative workflow. It wants to own certain things that it probably shouldn't own, like the whole hooks system. Anyway, I mean, the best way to use Helm is probably to use Flux Helm controller. Speaking of Flux, I wrote something else using a different tool for the Flux project, right? So remember how we were talking about YTT? It's this hermetic configuration tool that's supposed to build configs out of smaller pieces of code. Well, that sounds like another tool in the ecosystem, right? So we've talked about Helm, and then Kustomize kind of came into the landscape. Kustomize was saying, hey, maybe we don't need to do all of this complex control flow. If we write something that's very magically Kubernetes specific, we might be able to help people write some patches. And maybe they can factor their differences in their configuration out in this kind of additive tree structure. And people can overlay everything. So instead of doing this kind of if then else logic in the templates, let's just build YAML that builds up on top of other YAML, right? And so I wrote a couple of customized bases for the Flux project so that people could write some integrations. The problem that I have with Kustomize is that it's very limited. But the thing that I do love about Kustomize is that it uses way more overlays than Helm programs usually use. So what's good about overlays? Well, right here, I'm creating a deployment. It's got a bunch of non-trivial settings, right? But I can patch directly on top of this if I would like to do some special logic. So here, I'm patching this credential sync event hub deployment. And I'm just specifying that I would like an init container to be added, and that container should have some volume mounts. Right. So here I'm adding a kubectl binary to the rootfs that is being used inside of this other deployment object. Right. And so I don't have to mix the intention of I would like a kubectl binary, this 32 lines of YAML, with the intention from this deployment YAML. right? Which is its own longer config that has a shell script inside of it. And the nice thing about that is that the overlays help you separate these overly verbose, often they're Kubernetes configurations, but it just could be YAML problems from all kinds of stuff. Now, the problem that I have with Kustomize is that it's very Kubernetes specific. If you want to patch into init containers, you'll notice that this is a list. And the default behavior here is actually a strategic merge patch. So this container, if it's not present in this list, will be appended. But if it is present, will actually magically merge on this name field. And this is a very surprise and kind of non-trivial behavior. You have to know behind the scenes how Kubernetes API machinery likes to work. And if you want to do something different, like say just add a port to a particular container, or maybe you want to remove something. Like if I wanted to remove this init container using a patch, that's not really an operation that's possible. You would have to write some JSON patch specific thing that is index specific, and it's just the workarounds that you end up having to do when you start to use this tool are painful. Also, Kustomize really doesn't want you to create indirection. Let me show you what creating indirection in Kustomize looks like. So I can make a config map. I can include this config map inside of my configuration. My program at runtime doesn't actually need this config map. It's purely here so I have a place to put values. And then I can say, make a variable like sync period, and then go into my customization YAML. Actually, here, I already forgot what I was declaring. I want to declare this kube secret variable so I can control what secret my program creates. And then I want to create a variable, and I have to reference that field from the config map that I made just to store the value. And then in order for me to actually place it into the place that I want, which is in this role right here under the resource names field, in order to restrict the RBAC, I can do this kind of string interpolation, which feels very not type safe. And then I can go into the customize config and override the generator to allow me to, at this path with this syntax in roles, I want to be able to actually put the string into there, because Kustomize doesn't let me by default because it's very strict. So that's not super fun. Overall, this tool is it's very magical. And if you're not doing the most common use cases with it and your configuration starts to get more complex and you want to build some indirection interfaces for people to consume your add-ons and stuff, this really falls apart and it's painful. The compositions API is kind of okay in Kustomize. Again, I have a lot of pain with both of these tools. Helm being very monolithic with, frankly, not a great templating language for how complex those charts can get. And then Kustomize just being too simple and too Kubernetes specific for all of my general YAML problems. I've got tons of those, including a bunch of complex programming that I'm doing in GitHub Actions, right? So that rant was all purely to share the pain of why this tool speaks to me deeply. YTT is awesome. I love this thing. Structure-oriented. This fixes that problem with Go templates. Modularized config. I can break things up and turn stuff into overlays and start patching on top of each other. That's the best part of Kustomize. And it's deterministic, so I can trust that my programs are going to compile and execute the same way every single time. It's got overlays. It has intuitive templating, right? And so you'll notice, oh yeah, okay, this is a string. It looks like a command line flag, and I want to add a string, a type safe port to it, right? So this is probably a number somewhere, but I actually want to make sure it's a string. And this is just some simple concatenation. It looks like most programming languages if you've ever played with the programming language, right? It also works with any YAML. So this is not Kubernetes specific. If you want to mess with concourse pipelines, if you want to mess with Docker Compose, YTT is totally happy to help you with those problems, because we know that you have a lot of them when you are dealing with YAML in the cloud native world. And so the basic usage is that you can execute it on a folder, and then you could say pipe it to a kubectl apply, right? Or maybe you want to just output a bunch of YAML, or you want to output it into a directory structure and have all the files actually be sensible. That's the part that I like to do, right? So you go to this website, and there's an interactive playground. If you click here, demo, this is kind of a non-trivial example of how to use YTT. So here we have values. This is my favorite part of Helm. It's present here in the tool because I love creating abstractions. So here in my values, you can see my app has a couple of echoes. There's a list, and the first list item just has a name. The second list item has a name, and it also optionally is specifying a port and some text to output. And so just this 5 lines of YAML is my abstraction. I get to say to somebody, here's my app, here's how you configure it. And it's going to cut across the concerns of configuring it, in this case for Kubernetes, using the containers that are from the HashiCorp HTTP Echo registry, and then outputting them. So you see here, I have 2 containers. Well, what if I wanted a third one, right? I can name it here, and I can update my port, and then, maybe if we wanted to, we could. Okay. And so as you can see right here, I have added a third container here, and now the containers list has been expanded. There's also the port configured for the listen arguments on that container, as well as the output of the string inside of the output for the string for the web server. But in addition to that, the port configuration and the name of the container are used in the service down here. And so you can see I specify these details just once, but I can then create a YTT program to spread out that configuration across all of the different pieces of the infrastructure, whether that's a service or a pod or a role binding or endpoint list or something non-trivial in your Kubernetes configuration. You'll find this a lot with like host names for ingress controllers and things like that. Now, every YTT program is actually a valid YAML file. So here's how this program is actually written. We have YAML, and then we have comments. And inside of these comments, we're using a dialect of Python that's implemented in Go called Starlark. And you might have heard of Starlark before. That's because there is a popular project that we can actually use the libraries from called SkyCFG. And SkyCFG is kind of Kubernetes focused, but it helps you basically build cloud native configurations using Starlark. And what we've done that's innovative with YTT is we've empowered the system administrator, the infrastructure person, the developer to use something that feels a lot like Python directly within YAML, right? YAML is very limited. Most people don't even know how to use anchors and things like that. It's super weird. And then all of the types start to change on you because at first you were using a string, but then it was actually a commit SHA that you were putting in there. And now that commit SHA is all numbers, and now it's changed from a string to numbers. And like your deployment failed really surprisingly, and you were just trying to do your job. So what we've done here is we've added type safety, and we've added the expression and the Turing complete nature of Starlark, a Python dialect, right into all of these YAML comments. So here I'm defining a function, but this is still a valid YAML file. A YAML syntax highlighter is going to work. It's not, you're never going to get into a place where your Go templates are making your YAML not highlight properly. It's all confusing. And then here, I'm defining another function, but instead of outputting a map, I'm just returning a string. Here, we're defining a pod, right? And so since this is not inside of a function, this is kind of the main method. It's very similar to Kustomize in that way, where it's like if you have YAML at the top level, that's what's getting output. also similar in a way to Go templates. And now that we're in the labels section, we have a labels function being called. So we can imagine that this function would be called and then set the value of this field right here. But notice there's no indentation worries, right? Even though we would have to indent 4 right here in a Helm template to make sure that this is at the right spot, YTT understands the structure of YAML natively. It only ever is a valid YAML file coming in and a valid YAML file coming out. It will never produce invalid, improperly structured YAML that's going to blow up your CI pipeline or your Kubernetes cluster. So, and then here in the containers field, we have a loop, right? And you'll see this for end syntax. So I don't even have to worry about closing my loop later because it's just whatever is under this indentation level in YAML, very Pythonic, is a part of the loop. So here we can see that we're in a containers list. We make a loop. And then for every echo in data values, so we're getting these echoes from somewhere else, favorite feature of Helm, we're going to create a container. It's a container list item. We're actually going to call a function to then parameterize the name, and then we'll just hard code the image. And for the arguments, we will template out some string concatenation to get the command line flags. So here's where we set that listen port. We make sure to assert the type so that that's never going to change on us, although this concatenation also makes that happen. And then here in the text, we have the echo text for that from the data values, which is supplied here. So you can see that there's this very powerful indirection happening, right? We have a real programming language here. And if I had to share my own opinion, it's not ugly. It's not an ugly programming language at all. So I know that we've got a lot of Java developers here, a lot of programmers, and then a lot of people who've kind of migrated over to the stack. And as a developer who became an infrastructure person, looking at this is just beautiful to me. It's so much prettier than like a Jinja inspired template or a Ruby template or a Go template. And I don't have to worry about formatting and fighting the tool. I don't have to worry about the indentation. I don't have to be concerned with if I like wanted to add a label here, like I can just do a merge, and that's really beautiful. Here again, you can see in the service, right? If we want to do work on that same port data, then here we've got another loop, right? And so that's how these two pieces in the output are actually staying in sync. And there's also a schema. Right. So for the values that we're supplying up here, we can say that we can assert that these things are strings, basically, and that this is a Boolean in this service enabled true. That's actually cool. Here's a great example of the indirection again. I just pop into here. I can trust that since I copied from the schema, this is exactly what I need. And now I just say service enabled false, and the service no longer outputs, right? But then if I say true, it does output. And if I try to put something in here that doesn't match the type that it should be, then you can see that YTT says that it found an integer in the default YAML at line 12 when it expected a Boolean, right? So this is a real programming language. I can do real software development to actually build the distributed system that I need to deliver the software mission of my organization. I'm not messing around with messy bash scripts. I'm not throwing hope into the wind of grepping a commit message, you know, for a commit SHA and all of that stuff. I'm not praying that my Go templates compile in a way that my Kubernetes likes that day. This is testable. I can run assertions. I can load data values. I can create libraries. I can, here's the assertions. I have all of my control flow. I can make overlays. Overlays. So here, if we define an updates function that produces a map, here we can see that it's like a metadata annotations. Again, we're not messing around with any indentation or anything. This is just a normal snippet of configuration. And then we have an ingress. Say I wanted to put these these annotations on this ingress resource. And then I also had a different set of annotations. Well, I can just create a YAML document, replace that YAML document by overlaying the ingress with the updates. And then in this case, I'll do it again, but with both updates. And you'll see in the output that I have two slightly different ingress resources. I have a base configuration that's been modified by these annotations and then these annotations. Right? So this is really powerful. That's a lot like customize. Right? All I had to do was say overlay this with this. So let me show you some slightly more complex examples, and then we'll just get around to talking about these other tools as we kind of close out our presentation. Here, I have a very non-trivial control repo. This is a GitOps repo for a cluster that needs its authentication system set up. I'm using an add-on called Pinniped, and I have this Carvel folder. I got a bunch of stuff from upstream. Somehow I did that. I'll show you later in a second. If I go into my patches, you'll notice that I wanted to modify the ingress. Here, oh, sorry. Let's just look at the secrets. So here I'm saying like conditionally, let's add this secret to the mix. And then for actually patching the deployment, I define some updates. So this is my overlay patch here. And then I can look for this object, overlay match on that object. And then I can actually start changing the fields of that object. So here I'm looking for a config map. I'm changing it to a secret. And then I'm running like a Lambda function, right, to actually encode some YAML and like overlay on it. And so there's no concern about like indentation or anything like that. And you can actually see that I've made the configuration more secure. This is not going to be encrypted in etcd, but when I actually update the configuration with this patch, it's now a secret, so it will be encrypted. And then my updates can grab secrets, you know, from my values file and do all of this templating to make sure we're using the proper protocols and all of that. So this is very non-trivial programming, but it's the kind of abstractions that you'll find that you need to build when you're starting to manage maybe 10, 50 clusters, right? Maybe even 100 or a couple hundred. So I love YTT. You should definitely go check it out. Check out the playground. Right? Now, it would be such a crime like if I wasn't able to show you some of these other things. And unfortunately, we're just not going to have time to dive into every single one of these tools. I want to really encourage you to go to the Carvel Dev website, right? But I've got a couple of other micro demos for you, right? So if you go and check out CAP, you'll see that this is a lightweight CLI replacement, basically, for a bunch of the problems that you'd normally solve with kubectl. It's explicit and it understands dependencies. You can order CRDs. It knows to apply namespaces before the things inside of them. You know, make sure to wait for a job for running DB migrations before your deployment is updated. Those are things that you cannot do with kubectl. You have to write a shell script. Stop writing shell scripts. Use CAP. You know, it sorts and waits as needed. It plays well with other tools, so you can pipe anything that produces resources to install inside of your Kubernetes specific cluster. Whether it's a YTT configuration or a Helm template or a customized base, you can build all of those things. CAP doesn't care where your config comes from. It's not prescribing you a workflow. It's just trying to solve the problem of staying organized. And you'll see that if I look into a real Kubernetes cluster where I have an installation of Tanzu app platform, I have a bunch of apps, bunch of things, dependency management. And then in here, I've got like the accelerator. I have an installation of the contour ingress controller. Here's a cross-plane install, cert manager, cartographer. And CAP knows that all of these things are installed. It's very similar to like if you were to do Helm list, but it's only concerned with tracking all of the objects in your cluster. Similarly, if I were to like CAP inspect, so there's this scanning application inside of the tap install namespace. Then we can see that for this app, there's a bunch of cluster specific resources, and it's also only using one namespace. Right? So across namespace boundaries, and even when you're mixing apps in the same namespace, CAP can help you stay organized. It can tell you that your resources are successfully reconciled. It can say what it owns and what the cluster has created on its own. right? So there's a deployment here that's made a few replica sets, and the cluster owns those pieces, but Cat owns this part. And it shows you diffs. It's just a great, safer option with a lot of nice syntax highlighting and color highlighting for your diffs and all of that. Just try it out. It's really cool. All you have to do is add this -a flag when you're grouping things together. But otherwise, pretty similar to kubectl. The last micro demo I'll show you is kbuild. So say I have the smallest YAML file in the world, an Nginx latest image in a field. If I send this to kbuild, kbuild will go and look up the latest tag and tell me, hey, it's actually this immutable image SHA. Gosh, I can't tell you the number of times that I've deployed things to Kubernetes or to a Docker Swarm cluster or in my CI pipeline, and I've used a container image tag because it was the most convenient thing to do. Well, here I can actually pin to an immutable SHA, and that container image underneath will never change, even when we're doing rolling updates and stuff is failing underneath the cluster. And you get all of these kinds of surprising failures because the image was updated inside of the container registry, but not inside of your cluster, right? So you can see these little tools, they solve very specific problems. Vendor here, like you can go and just make a YAML file and get a single file from a Git repo. You can go and get stuff from HTTP and then build a directory of all of those things, right? So these tools, they solve your problems, and I would encourage you, just go check out the website. And if you want to ask me more questions about where this repo is, if you want to look through my examples and that kind of thing, I felt a lot of pain, and this tool suite, it speaks to me. It speaks to me as an infrastructure person who's had to glue a lot of stuff together over probably a career that's even shorter than yours, right? I'm sure you felt probably a lot more pain than me. So yeah, thanks everyone. And I will be in the chat. Go ahead and ask me questions over there, and I'll be handing it off to my awesome teammate Cora here for the next presentation. We've got awesome stuff lined up for you today. So cheers.